Welcome. Today we're doing a deep dive into a really acute challenge, one that affects emerging markets all over the world, but we're focusing in on Nepal.
Right.
And we're asking a pretty fundamental question about technology. Can something like artificial intelligence or agrotech help a nation completely leapfrog its massive infrastructure problems?
You mean things like bad roads, not enough cold storage?
Exactly.
Yeah.
Can AI solve what's being called a catastrophic post-harvest crisis?
It's a powerful idea.
Yeah.
And the scale of this problem, it's genuinely staggering. I think to really get it, you have to visualize the journey.
Okay.
Picture a truck. It's loaded with something high value, perishable. Maybe it's fresh ginger from the eastern hills, maybe tomatoes from Toding.
And it's on the Prithvi Highway.
Laboring up the Prithvi Highway. That whole journey is just a fight against time, against the terrain, against the heat, all just to get to the Kalamati market in Kathmandu.
And we're not talking about a refrigerated vehicle here. This is an entire harvest on a truck that's built for durability, not for, preservation.
Not at all. And here's the devastating part. Everyone involved, the farmer, the transporter, the wholesaler, they all know that by the time it arrives, somewhere between 20 and maybe 30% of that cargo will be unsaleable.
It's spoiled.
Spoiled.
Yeah.
From the bumps, the transit time, the temperature. Now, scale that loss across the entire country. You're looking at an estimated 25% of the agricultural GDP just eroding silently year after year.
25%. I mean, that's not just inefficiency. That is a foundational drag on the whole economy.
It's a systemic tax on the nation.
So the obvious diagnosis, the one you always hear, is we need more roads, we need better cold storage. But the sources we've looked at for this deep dive suggest those are just symptoms. The real root cause is informational.
Precisely. The core issue is a chronic information asymmetry and a profound, truly paralyzing data deficit.
Yeah.
So our mission today is to understand why this spoilage really begins as an information collapse.
And how predictive analytics is being pitched as the solution, a sort of central nervous system for a supply chain that's currently just chaotic.
Right.
Okay, let's unpack that. How do we get from a physical problem, a truck of rotting tomatoes, back to a data gap? Why does the spoilage start in the field?
It all starts with instability. And there's actually a term for this in supply chain management. The bullwhip effect.
The bullwhip effect.
It's a perfect description for what's happening.
Uh-huh.
It refers to how these small fluctuations in demand from consumers in, say, Kathmandu or Pokhara,
Okay.
they become wildly amplified the further back you go up the supply chain.
Can you walk me through that? So if I, as a consumer, buy 10% less rice this week, how does that become a 40% disaster for the farmer?
Well, think about the chain of decisions. A wholesaler in Kalimati sees demand as a little soft, so they place a slightly smaller order with their regional aggregator, maybe 10%
That
less.
seems reasonable.
But the aggregator, they get worried. They see that dip and think about future risk, so they add a safety margin and place a 20% smaller order with the cooperative.
Ah, so it's already doubled.
And the cooperative, which has no real foresight, they panic about a potential glut. They might just completely slash the amount they agree to buy from their smallholder farmers.
And the farmer is operating on information they got last year.
Or just copying what the next village did.
Yeah.
They've already planted based on expectations that are now completely gone. They have no idea that, say, a new highway just opened in India, changing import prices, or that a couple of big festivals are scheduled late this year, which will shift demand peaks.
So that small 10% dip in cardamom sales in the city
Becomes a 40% price crash for the farmer in Taplejung who just harvested his entire crop based on old, useless information.
The consequence of that information vacuum is just brutal. The farmer is totally disempowered, a price taker. The apple grower in Mustang has, zero real-time visibility into demand in Pokhara?
Zero. And that opacity, that's what allows these extractive little men to thrive. They exploit the farmer's ignorance.
And it's not just the farmer. This data blindness must infect logistics, too.
Oh, absolutely. A transporter is basing their route on static stuff. Distance, tolls, fuel costs. They are not factoring in dynamic variables. The risk.
What kind of risk?
Well, what's the probability of a landslide closing the Mugling Naryang Hat Road for 12 hours? Or the chance of a political strike shutting down transit in the Terai?
Both of which add these crucial unplanned hours, and that's when fresh ginger turns into spoiled ginger.
Exactly. And the whole system just oscillates between glut and scarcity because the market can't send clear signals.
This sounds like a perfect problem for a computer to solve. And this is where it gets really compelling, right? Predictive analytics is pitched as this this central nervous system, to fix it all.
Yes, it's about shifting the whole mindset from being reactive to having optimized foresight. We could really break it down into three strategic areas: demand, movement, and pricing.
Okay, let's start with demand and yield forecasting. How does that help a farmer making a decision about planting 6 months from now?
Well, the models are trained on really rich data that goes way beyond just what sold last year. Imagine a big cooperative in Joppa. They're now integrating multiple data streams.
So not just their own sales records.
No, they're pulling in historical planting data, yes, but also satellite imagery to assess crop health and estimate yield. They're looking at long-range weather forecasts. And critically, they're pulling in real-time price data from competing Indian markets. The Mandi is in Bihar.
So they're connecting their own reality on the ground with the much bigger regional competitive landscape.
Precisely. And the goal is to shift the farmer from harvesting when the crop is physically ready to harvesting when the market is projected to be ready.
Which would allow for strategic, staggered planting.
Smoothing out supply.
Exactly. It prevents those crippling seasonal gluts.
Okay, that's a huge shift in farm strategy. Now let's get back to our truck. The physical logistics. What does a predictive model do there that's more than just a better GPS?
It's so much more. The core goal of that logistics model is to minimize something called the spoilage risk index. The spoilage risk index?
It's a dynamic calculation.
Yeah.
It's the overall probability of loss for that specific cargo in real time. It integrates dozens of variables. The specific shelf life of the product tomatoes versus potatoes is a huge difference.
Of course.
The installation of the truck itself, real-time traffic, and most importantly, historical data on road blockages.
So if the model sees a 60% chance of a 5-hour closure on the main route because of landslides, it might actually suggest a longer route.
It might suggest a completely different, longer, and maybe even more expensive route.
Okay, but doesn't that just trade one problem for another? If we're raising transport costs to avoid spoilage, aren't we just pushing that cost onto the consumer?
That is an excellent question. And the model has to optimize for the total systemic cost, which includes the value of the lost goods.
Ah.
So while the alternate route might have a higher toll or use more fuel, if the original route has a high risk of, say, 30% spoilage, the longer, safer route might actually result in a higher net revenue, because more of the product actually makes it to market.
The model is prioritizing preservation as the main driver of value, not just the lowest transport cost.
It fundamentally shifts the entire focus of the system.
And the third piece of this puzzle is price prediction. This seems to aim right at that core problem we talked about, the information asymmetry.
It's the great equalizer. I mean, imagine giving a farmer a reliable 7 to 14-day price forecast.
Oh, how would that even work?
By aggregating data from all the major hubs, Kalamati, Bertamad, Butwal, and combining it with import volumes and known demand drivers, things like national festival schedules.
Which create these huge, predictable surges in demand that everyone sort of knows about, but not in a quantifiable way.
Exactly. With a reliable, objective forecast, the power dynamic just shifts. When a middleman shows up offering a low price on the spot, the farmer can push back with a data-backed estimate of what the market will look like next week.
So we've got the use case, we have the technology, but here comes the reality check. The source material is very clear on this. The primary barrier isn't the tech, it's the data.
It is.
What is this colossal data deficit?
It's the hard truth. The foundational data you need to train any of these models. It's either non-existent or it's scattered into completely useless fragments. You can't predict the future when you haven't even recorded the recent past.
But so it's trapped in old paper ledgers in some district office.
That's part of it. Or it's digitized, but it's sitting in a dozen different uncoordinated databases owned by different government agencies, co-ops, private traders.
So it's not just a lack of data, it's a lack of standardization.
Yeah.
A lack of accessibility.
That's the key. One co-op might measure quality by weight, another by visual grade. The AI tries to look at that and just sees noise, not a clear signal. The daily price bulletin from the Kalamati market is a good start, but it's described as an island of data in a vast ocean of ignorance.
For a contrast, we have to look south. India's agrotech giants like Ninjacart and Waycool have made this work. What was their blueprint?
Their blueprint was deliberately unglamorous. They did not start with complex AI. They started with the huge, expensive task of building the data pipeline first.
What does that mean in practice?
It means they deployed thousands of field agents, people with digital devices with GPS trackers, to manually digitize the entire flow, from the soil to the truck to the shelf. For years, they just accumulated this rich, proprietary data set by brute force.
They owned the data stream from end to end, and that data set is now their competitive advantage.
Exactly. They got data density first, then they deployed the analytics. But, and this is crucial, the sources are clear that Nepal can't just copy-paste that model.
Why not? Why is the difference insurmountable?
Scale. Nepal's agriculture is dominated by millions of tiny smallholder farmers. I mean, many are farming less than 1 hectare.
Right.
So the unit economics of sending an agent out to digitize a farmer who's producing just a few hundred kilos of vegetables,
Yeah.
it's incredibly challenging. Replicating India's massive agent-led model is just too expensive for any single startup in Nepal. The ROI is too low.
So Nepal needs a more capital-efficient way to get this data.
It has to innovate.
Which brings us to the strategic path forward. If a typical startup can't just parachute in and solve this, what are the most likely scenarios for actually getting this done?
The sources point to two probable paths. The first, and maybe the most immediate, is the rise of what you'd call a vertically integrated data player.
Okay, so you're talking about large, established national players who already control big parts of the supply chain.
Exactly. Think major logistics companies, big food processors like DDC, or large retail groups.
And their motivation isn't solving the national crisis, it's their own bottom line, internal efficiency.
Precisely. They start by instrumenting their own fleets, their own warehouses, their own supplier networks. They build a high-quality data set to solve their problems first.
But then what?
After 2 or 3 years, that data asset becomes so powerful and their own operations become so efficient that they can start offering their logistics and forecasting platform as a service to smaller businesses. They sort of accidentally become the data backbone for the whole sector.
Okay, that's one scenario. What's the other?
The second scenario is more of a policy-led approach, the creation of a public-private agricultural data stack.
This sounds like a strategic government intervention.
It is, yeah. Ideally with support from donors like the World Bank or the ADB. And the key here is that public investment should focus on building foundational infrastructure, not applications. The goal is to create this data stack as a kind of public utility.
And what are the key unglamorous pieces the government absolutely has to finance to make that work?
It boils down to 3 foundational things. First, a national open API. It would mandate that all major agricultural markets publish real-time, machine-readable data on price and volume.
Total transparency at the point of sale.
Second, a standardized digital identity system for all registered co-ops and agribusinesses, so you're replacing paper trails with standard digital records. And third, a subsidy program for the boring but essential hardware, like GPS trackers and basic temperature sensors in all commercial farm transport.
And that's the critical insight, isn't it? By creating this public utility of data, you just fundamentally lower the barrier to entry for everyone else.
Exactly. Hundreds of small startups can then focus on building the cool stuff, the analytical models, the AI, the apps, instead of each one wasting capital trying to reinvent the data collection wheel.
It democratizes the information.
It does. The failure isn't a lack of clever code, it's a lack of ordered information.
So to synthesize this whole deep dive, the catastrophic failure in Nepal's supply chain is informational, not just physical. And the winners won't be the AI purists, but the data aggregators, the ones willing to do the hard, manual work.
And that leads to the hard truth from all of this. AI is not some magic wand that lets you bypass the need for infrastructure. It's a powerful amplifier, but it needs something stable and cleaned to amplify. So the solution to the tangible problem of rotting produce, it starts with the intangible, disciplined work of creating order from information chaos.
Which leaves us with a final provocative thought for you, the listener. Whatever your industry is, if it relies on an efficient supply chain, manufacturing, retail, even pharmaceuticals, you have to ask, where are your equivalent data deficits? What is the core, unglamorous infrastructure, that foundational data stack that you have to build before any of the high-tech predictive solutions will ever actually work for you? Because the challenge today isn't acquiring the algorithms, it's acquiring the clean, accessible data.